Okay, today I'm going to go over how to use the ideal gas law. That's the PV equals nRT equation. And so I just want to go over a few things about the equation in general before we get started learning how to use that. So the first thing is you're not really going to know exactly which equation in the gas law unit you need to do until you identify the givens, because we have like Boyle's law here, we have Gay-Lussac's law here, we have Charles's law here, we have the combined gas law, and then right here we have the PV equals nRT equation. So what I would recommend doing is just kind of reading the problem, and if the problem mentions like moles or grams or anything like that, so if it mentions moles or grams, there's probably a good idea you're going to use PV equals nRT, because if it has moles in it, definitely, and if it says grams, there's a good chance you're going to use it because you can always change grams to moles. All right? Whereas if you're doing this problem and you start identifying the givens, like this one, you have like P1 is equal to 2 atmospheres, and then you got V1 is 3 liters, and T1 is 5 degrees Celsius, and it's looking for new temperature when the pressure, so P2 is 3 atmospheres, and the volume V2 is equal to 7 liters, and it wants to know what is the new temperature, so it wants T2. See, this problem doesn't mention anything about moles or grams. This one you would need to use the combined gas law for. Okay? Now, the second thing is, when using the equation PV equals nRT, so let's say we're going to use that equation, all right? When you use PV equals nRT, there's this ideal gas law constant R right here. Now R is given on here, and we're giving you these numbers. Okay, you don't need to memorize them, but each type of pressure has its own specific unit. So the 3 units of pressure that you will possibly encounter in this chemistry course are kilopascals, millimeters of mercury, or atmospheres. So when you're trying to do a gas law problem, you have to match the R in the equation to the correct pressure unit. Okay, I'm going to demonstrate that on all the problems that we do today. All right, so let's go ahead and try the first one here. So how many moles? Okay, right away that says moles. So I know that I'm going to need to use PV equals nRT. So I'm going to make a list, PV, nRT, and I'm going to write them down. Okay, how many moles of gas? So hey, moles is the N. Okay, that's moles. N stands for moles. RNA 2 liter, that's V, 2 liter. Empty soda bottle sitting on a kitchen counter. If the room is 22 degrees Celsius, this is supposed to be T here, so 22 degrees Celsius. Okay, and the pressure is 1.01 atm. Now there's a couple rules about using PV equals nRT. The pressure has to be either in kilopascals, millimeters of mercury, or atmospheres, okay? That's what unit it will always be in this class. However, volume could be in milliliters or liters, but the volume has to be in liters, so your V has to be in liters. Okay, N, that stands for moles, that has to be in moles. R, you're just going to pick the correct one that matches your pressure. However, your temperature always has to be in kelvins, so you would add 273, and so 5, this is going to equal 295 kelvins. So you need to make sure your units match before you start it. Okay, so now I'm going to show you the math. So how I do it is I write down the problem. Before substituting any numbers, I'm going to move the variables and solve for the one I need. So what I'm going to do, everything's on the top. I'm going to draw a line underneath everything. And I'm going to isolate N. So N is on the top, and so I need to move RT. Everything moves diagonal. Okay, so if it's on the top, everything's going to move diagonal. So RT is going to move diagonal over here. Basically, you would divide both sides. This side cancels out. And so then you get this equation. N is equal to PV over RT. Then it's just a matter of plugging in the numbers. N is equal to P, 1.01, times V, 2.00, divided by R. Okay, now I forgot to do this. We have to pick the R value. To pick the right R value, we look at the pressure. It's in atmospheres, so we look for the one that's in atmosphere. So that's the 0.0821. Okay, these numbers are on page 4 of your formula sheet. So the R has to match the pressure unit. Okay, so the R will be 0.082 and the T is 295 kelvins. So now if we take on the calculator, push the buttons with me. Some people I noticed on the last quiz had the problem. So you're going to take 1.01 times 2, then you're going to divide that by 0.082, hit the divide button again, okay, because it's on the bottom. You divide by everything on the bottom, and you should get 0.084. Okay, and N is, the unit is moles. Okay? Okay, let's try another one. So, number 2. What is the volume of 4.5 grams chlorine gas when under the following conditions? 114.6 kilopascals and 34 degrees Celsius. All right, why don't you pause the video here, and I want you to see what variables you can identify in the PV Nrt. Pause the video and see what you can identify. Okay, so pressure is 114.6 kilopascals. Okay, temperature is 34 degrees Celsius. Okay, now we know what our R will be because we got to match the pressure unit to the R unit. So R is going to be 8.31. Okay, now it says what is the volume? That's what we don't know. Okay, but it doesn't give us the moles. However, it gives us the grams. It says 4.5 grams chlorine gas, Cl2. So we can just use a short picket fence and change to moles. 1 mole chlorine, and it's 71 grams. That's the molar mass of Cl2 is 71. And so that equals 0.063 moles of chlorine gas. Okay, so now we have all of our units accounted for. Now we're just going to write the equation, PV equals nRT. Okay, we're looking for V, so we draw a line underneath both. We want to get V by itself, but P needs to be moved away. Everything moves diagonally, so it's going to move right over here. Basically, we divide both sides by P. This side cancels. So V is equal to nRT over P. So then we plug in the numbers. So N is 0.063 times R, 8.31, times T. Oh, I forgot. I got to change to kelvins. Never forget, change to kelvins. Okay, so that's 307 Kelvin. I almost forgot. Okay, divided by P, which is 114.6. Okay, so you do all that math, and V will equal 1.4 liters. Okay, what I'd like you to do is just to pause the video, and I'd like to see if you can do this problem by yourself. Then restart the video and check your work. So pause it now, try this one on your own. Okay, here we go. So let's list the givens. P, V, N, R, T. So we write them down. And then we go, okay, what is the temperature? Okay, we're looking for the temperature of 6 moles. So 6 moles of carbon dioxide in 435 milliliters container at 450 millimeters mercury. So we have millimeters mercury here. So we can get our R by looking on the formula sheet. And so we're going to use the 624 because that's the millimeters of mercury. Okay? Now, before we do this, we got to make sure our units are correct. Remember, volume always has to be in liters. We're going to have to change this milliliters to liters. So in 1 liter, there's 1,000 milliliters. So if you do the math, you would get oops, I don't know why I did that. Okay, so it's going to be let's see here, I gotta get my pen to work. All right, so 0.435 liters. Okay, so make sure you do that. Now we write our equation, PV equals nRT. Okay, so we're looking for T. We draw a line under both sides. We got to move NR from the top over to the other side to get T by itself. Everything moves diagonally, so NR will go there. On this side, you just divide both sides by it. That's how you move it. And so we get T is equal to PV over NR. Then we just plug in the numbers. T is equal to P, 450, times V, 0.435, divided by N, which is 6, times R, which is 62.4. Okay, so you'll take 450 times 0.435 divided by 6 divided by 62.4, and we would get T equals 0.52. Now you might wonder what the units are. Well, whenever you do a gas law problem with PV equals nRT and you're solving for T, the units that you'll be getting will be kelvins, okay? All right, next problem. All right. How much pressure is exerted on the walls of an 11.2 liter kickball if it contains 0.02 moles of nitrogen gas and 0.03 moles of oxygen gas if the ball is 24 degrees Celsius? Okay, so why don't you pause the video and try this one. The only tricky part with this one is it's giving you 2 mole numbers, but remember Dalton's partial pressure, that the total pressure is going to be equal to the pressure of gas 1 plus the pressure of gas 2. Okay, so you just have to add these pressures. Oh, no, what am I doing here? That's not what I'm doing here. Okay, excuse me. So it's asking for the pressure. We don't need to know this Dalton's law of partial pressure. We need to add the moles together to know the total moles in the container, because more moles will create more pressure. So anyway, add the moles together. Okay, so why don't you list the givens? So pause the video, list the givens, see if you can solve it. Okay, let's list the givens. Okay, so how much pressure? That's what we're looking for. The volume is 11.2 liters. N, okay, well, we got 0.020 moles plus 0.003 moles. So we're going to have to add those together, and you would get 0.023 moles. 0.023 moles. Okay, R. Okay, well, this problem doesn't, it just says how much pressure. It doesn't say which one. Okay, so let's just work in atmosphere. So I guess we get to choose which unit we want. So we'll choose atmosphere. So our R, if we use the R that has atmospheres in it, our pressure will be in atmospheres. Okay, our temperature is 24 degrees Celsius. So we have to add 273 to that. Make sure you always change to kelvins. So that ends up being 297 kelvins. So we write our equation, PV equals nRT. Okay, we draw a line under both sides. We're looking for P. So let's move V diagonal by dividing both sides by it. So P is equal to nRT over V. Let's plug in what we got. So P is equal to 0.023 the moles times our R is 0.082 times our T, which is 297, divided by V, which is 11.2. So P, if you take, you take this times this times this, divide by 11.2, and I got 0.050, and because you use the atmosphere R, your units will be in atmospheres. Okay, one more problem. Okay, try to set this one up yourself and see if you can solve for the pressure of the gas, okay? So pause the video, set it up, see if you can do it. All right, so first of all, let's list the givens. P, V, N, R, T. So, all right, 24 grams. Well, there is no gram thing here, but we know that we can change grams of hydrogen. We can change that to moles using the molar mass. 1 mole of H2 equals 2 grams of H2. So that's going to equal 12 moles of hydrogen gas is injected into a 5-liter, okay, that's volume, 5-liter container at 25 degrees Celsius. Remember, we have to add 273. We always got to work in kelvins, 298 kelvins, okay? What is the pressure? So we're going to find the pressure, but it wants it in millimeters of mercury. That means we have to use 62.4 for our R value. That way we'll get the P, the pressure in millimeters mercury. So we write PV equals nRT. Okay, we're looking for pressure, so we divide both sides by V. Remember, V is moving diagonally, this side cancels. So P is going to equal nRT over V. Then we just plug in the numbers. So we put in 12 times 62.4 times T, 298, divided by the liters, which is 5. Okay? So the pressure is a pretty big number if I remember right. So it looks like it's 44,628. And since we use the 62.4, which is the millimeter of mercury one, our pressure is in millimeters mercury. Okay, so that's it for this video. I hope that helped you with the PV equals nRT problems.